Hello everyone. In this video, I am going to tell you about the casting defects. The casting defects include thinning of the casting, dimensional changes, distortion, discoloration, and surface roughness and irregularities. Let's first start with the surface thinning. The causes for the surface thinning include heating the investment too rapidly, if the investment is dried completely before it is heated, and because of the repeated heating of the investment. This animation details the formation of surface fins because of rapid heating of the investment. When the investment is rapidly heated, the outer walls of the investment are at a higher temperature, whereas the inner walls, that is the mold walls, are at a lower temperature. And because of this temperature difference, the outer wall, which is hotter, shows more expansion, whereas the inner wall, which is cooler, shows less expansion. And because of this difference in the expansion, the inner wall is under tension, whereas the outer wall is under compression. And this tension on the inner wall, that is the mold wall, leads to the formation of cracking, and this cracking is seen in the form of fins on the surface of casting. The next casting defect is dimensional change, and the cause of dimensional change is an imbalance between the casting shrinkage and mold expansion. As the investment sets, it undergoes normal setting expansion, and when it is heated for burnout or for casting, it undergoes thermal expansion. And both this normal setting expansion and thermal expansion are sufficient to counteract the casting shrinkage of the metal or of the alloy. But in case a higher water powder ratio is used, the achievable normal setting expansion is reduced, and because of this, the casting shrinkage cannot be countered, which results in the formation of a smaller casting. The next casting defect is distortion, and distortion is caused by the distortion of wax or uneven setting expansion of investment. The wax pattern distorts due to a change in the temperature. At a higher temperature, the wax becomes soft and it flows, because of which the shape changes, and at a lower temperature, the wax contracts, and since it has a higher coefficient of thermal expansion and very less conductivity, the thicker sections show higher contraction, whereas the thinner sections show lesser contraction, and because of this uneven contraction, the wax pattern distorts. In case proper water powder ratio of the investment is not used, then during setting, the investment might expand and compress onto the wax pattern, which leads into the distortion of the wax pattern, and a distorted wax pattern would result in the formation of a distorted casting. The next casting defect is discoloration. The causes for discoloration include decomposition of the investment or incomplete wax burnout. During the burnout procedure, if the temperature of investment is raised too high, for example, in case of gypsum bonded investment material, if the temperature is raised above 700 degrees Celsius, then the gypsum bonded investment material, that is the calcium sulfate dihydrate, decomposes to release sulfur dioxide gas, and this sulfur dioxide gas is absorbed on the surface of the molten metal, which upon solidification results in discoloration of the casting, though this discoloration can be treated by pickling, that is by the treatment of casting with a dilute warm solution of hydrochloric acid. In case of an improper burnout, the carbon from the wax pattern might still remain in the mold cavity, and this carbon, upon heating, reacts with calcium sulfate to again release the sulfur dioxide gas, and the sulfur dioxide gas results in the discoloration of the casting. The next casting defect includes surface roughness and irregularities. The causes for surface roughness and irregularities include air bubble on the wax pattern. Air bubbles on the wax pattern are caused due to hydrophobic nature of the wax, which can be treated by coating the wax pattern with a detergent or a surfactant solution. The next cause is water film from the investment, which results because of the excess water present in the investment material. To treat it, a proper water powder ratio should be followed. The next cause is the rapid heating of mold. Rapid heating of mold might result in the disintegration of the mold wall, which can result in a rough casting. The next cause is the size of the silica particle. Larger silica particles can project into the mold surface, which might result in a rough casting surface. The next cause is too high casting pressure. Pneumatic casting machines are used in case of base metal alloys, and a casting pressure of 1 atmospheric pressure is used. But if the casting pressure is high, then the molten metal would impact on the walls of the mold, and this impact results in the disintegration of the wall, which would again result in the formation of a rough casting. To remediate, the casting pressure of 1 atmospheric pressure should be used. The next cause is the impact of molten alloy on the mold wall. Apart from the high casting pressure, an improper sprue attachment, that is, if the sprue is attached at a 90-degree angle to the wax pattern, it will also result in the impact of molten alloy on the mold wall, and this impact would result in the disintegration of the mold wall and rough surface of the casting. To prevent it, the sprue should be attached at an angle of 45 degrees to the wax pattern, so instead of a turbulent, a lamellar flow of the molten metal can be achieved into the mold. As you can see in this animation, when the investment is being poured, and if the wax pattern is not being coated with the surfactant, then since the wax pattern is hydrophobic, the investment fails to wet the wax surface, and this results in the formation of bubbles on the surface of wax pattern, and these bubbles are expressed in the form of surface roughness on the casting surface. That's all, friends. I hope you like this video, and if you find this video helpful, please like, comment and share, and please don't forget to subscribe. Thank you.